Hello there. This video is going to be kind of an extension from the last video, and you're going to learn a new conversion factor. So that's going to be good fun. So let's take a look at example 10-7. It says how many grams of bromine are required to react completely. What is going on with my pen here? Okay, hang tight. So it says how many grams of bromine are required to react completely with 45.70 grams of lithium iodide. So what I need to do is I need to go ahead and write down my reaction. How many grams of bromine are going to react with lithium iodide? So bromine is Br, but it's a diatomic, so I need to make sure I put Br2, and it's going to react with lithium iodide. Okay. Well, it doesn't tell me the rest of the situation. It doesn't tell me my products. Okay. Remember, this is one that we can predict the products on. Okay. So what's going to happen here is that bromine is going to switch places with iodine for a single replacement reaction. Okay, so this one's going to single replace. Now, the reason that bromine is going to react or is going to switch places with iodine is because they're both nonmetals. Okay, so then I'm going to end up with I2 plus LiBr. Okay, we need to make sure that this is balanced. So in order to balance it, I'm going to put a 2 here and a 2 here. So now I've got two bromines, two lithiums, two iodines, and two iodines. Okay, so now my next step tells me that I need to find out what my given is, and I'm going to write my given, 45.70 grams, underneath lithium iodide. Okay, so lithium iodide's here, 45.70 grams, and I'm trying to find out how many grams of bromine are going to react with it. Okay, well, bromine is right here, so I'm trying to get to question mark grams. So what I need to do now, I can't go from here straight over to here. Okay, but what I can do is I can get to my mole road. Okay, in order to do the mole road, I need to get everything into moles. Okay, can I go from grams to moles? Yes, using my molar mass conversion, I can get from grams to moles. Okay, now that I'm at the mole road, I can use the mole road to go over the bridge to the other thing that I'm looking at. Okay, so I can now go from moles of this to moles of bromine. Okay, and now I can go from moles of bromine. I can use a molar mass situation now to go from moles of bromine to grams of bromine. So what I'm going to do now is I'm going to use this as a roadmap for my T-chart. Okay, I'm going to start off my T-chart with 45.70 grams of lithium iodide. And I'm going to go from grams of lithium iodide to moles of lithium iodide. I'm going to go from moles of lithium iodide to moles of Br2. And I'm going to go from moles of Br2 to grams of Br2. That's why we love the mole road, is because it writes it out as a roadmap. That's exactly what it is. Okay, so now I know that I have to shift everything down and to the right. So grams of lithium iodide is going to go here. Moles of lithium iodide goes here. Moles of Br2 goes right here. Okay, so now I need to plug in the things that I can. Moles compared to grams. Okay, moles compared to grams. I know that this is going to be a situation where I put 1 in front of the moles and a molar mass with lithium iodide. Lithium is 6.97 plus iodine is 126.90. Oh, lithium, I'm sorry, 6.94. And I get 133.84 grams. Okay, moles of bromine compared to moles of lithium iodide. Now, we used to always put 1 with the mole. Okay, that's not the case now for Unit 10. Anytime I have moles over moles, Anytime I have moles over moles, I have to put the coefficients in. Okay, so my coefficient for lithium iodide is right here. It's a 2. My coefficient for Br2 is just 1 because I don't have a coefficient there. So I'm going to put a 1 in right there. Okay, now I've got moles of Br2 compared to grams of Br2. So 1 goes with moles, and bromine is 79.90 times 2, 159.8 grams of bromine is the same thing as 1 mole of bromine. Okay, so now my T-chart is set up. I'm going to circle this because this should be my final unit, which is exactly what I'm looking for. Grams of bromine are what I'm looking for. So I'm going to write that. I got some room over here. So grams of bromine is my unit. So now I'm just going to do the math. 45.70 times 159.8. Enter. Divided by, okay, now I've got 133.84 and 2 on the bottom. So I need to open parentheses, 133.84 times 2, close parentheses, be careful of your order of operations, hit enter, and I get 27.28, and that is the appropriate amount of sig figs, grams of Br2. Okay, that is how these problems work. Okay, let's do another one where we are, well, let's switch it up just a little bit. How many molecules? Oh, this is a good one. This is a good one. I love this. All right, so now, in fact, it's so awesome, I'm going to change colors for it. Let's do purple. Okay, how many molecules of hydrogen gas are required to react with 0.334 grams of nitrogen gas in the synthesis of ammonia? Okay, so this problem tells me I'm starting off with H2 plus N2, and that yields NH3. Easy enough. I need to balance this, so I'm going to put a 3 here and a 2 here, and that should make it balanced. My next step is that I need to take my mass of, or my given, and put it with what it's describing. Okay, 0.334 grams describes nitrogen gas. So I'm going to put 0.334 grams underneath nitrogen gas. What am I trying to get to? I'm trying to get to question mark molecules of hydrogen gas. Now, this is a little bit different situation because I'm not going from grams to grams necessarily. Now I'm going from grams to molecules. Same situation, we need to follow our mole road. Can I get from grams to moles? Yes, through molar mass. Okay, now that I'm at the mole road, I can go from moles of this to moles of that. Can I go from moles straight to molecules? Absolutely, I can. Okay, I can use my Avogadro's number um, conversion to get there. Okay, so now I need to make my mole road, okay, or make my T-chart, and I'm just going to use my mole road as a template for how I need to fill in my blanks. So first I've got 0.334 grams of N2. Okay, I'm going to go then to moles of N2. Then I'm going to go from moles of N2 to moles of H2. From moles of H2, I'm going to end up at molecules of H2. Okay, so now let's bring everything down. Grams of N2, moles of N2, moles of H2. Okay, so I am going to plug in the numbers that I can. 1 mole of N2 is the same thing as 14.01 times 2, which is 28.02 grams. That's the molar mass. Okay, I've got a mole to mole situation now, so I'm going to put in the coefficients. My coefficient for H2 is 3. My coefficient for N2 is 1. And lastly, I'm going to do moles to molecules. Okay, I know that 1 goes with moles always, except for mole to mole. Okay, 1's going to go with moles always. And then molecules, what number goes with molecules? How about Avogadro's number? 6.022 times 10 to the 23rd power. Okay, So now all I have to do is circle my unit, which is molecules of H2, and write that down. Okay, and now I'm going to do the math. 0.334 times 3 times 6.022 second E23, enter, divided by, oh, poo, I just hit 0.334 times 3 times 6.022 second E23, enter, divided by 28.02, enter. And I get 2.15, yes, to 3 sig figs. So 2.15 times 10 to the 22nd molecules of H2. Okay, that just gives you a little bit of insight, a little bit more. Man, did that take us that long? Holy smokes, it took us 10 minutes to do 2 problems. Okay, so we're going to do another problem, another mass to volume, or we're going to learn a new situation in the next video. See you there.